This is Professor Eckhouse, and I'm going to talk today about how to add and subtract fractions that do not have a common denominator. So it suddenly gets very much more complicated finding common denominators. So adding and subtracting, different rules in multiplication and division. All right, so how can we combine fractions without a common denominator? So before, what we were doing is, we were taking these things and we were just kind of moving them over. But if they're not divided into the same size, it's really hard to do that. So if you tried putting the 1/2 and the 2 1/3 together, you're going to get some overlap. It's going to just be kind of a mess. So if you estimate it on a number line, that's another way to kind of think about it. So let's put that 1/2 on there and the 2 1/3. So here's our 1/2 plus 2/3. And we end up with a number that is, somewhere in there. So right in here. And so if each one of these is 1/4, how did I figure that out? Well, I counted them. 1, 2, 3, 4. So I've got 1/4, 2/4, 3/4, 4/4, which is another whole. Okay, I'm kind of making a mess here, so let me fix this. So our number is lying right here. So it's like a little less than 1 1/4. Okay, so if it's 1.25, if you've converted it to decimals, which you're going to be doing soon, you could think of it as somewhere in there. Okay. So, but we don't want to estimate. We want to actually be able to add. So what we're going to do is we're going to look at the least common denominator of two fractions so that we can add them together. Now, this is the only time I'm really going to show you a picture like this, which the number line and everything going together. So take a moment to look at what I'm doing here. So we've got a 1/2 plus 2/3, and it's estimated to be over here. So we don't want to estimate. So what we do is we find a way to divide 1/2 and 1/3 into equal parts that are the same size. And we find that 1/6, this goes into 1/2 3 times, right? And we've got 1/6 also goes into 1/3 2 times. And there's 2 sets of them here. Okay, so we've got 3/6, and we've got 2/6, and we've got another 2/6. And now we find that we can add all those together, and we're going to do that in just a moment. But right now I want you to think about what the least common denominator is. What is the least common denominator of 1/2 and 1/3? What is the least common denominator? And that is that 6 right there. It is 6. That is the least common denominator of 1/2 and 1/3, or the least common multiple of 2 and 3. Okay? The least common multiple of 2 and 3. So least common denominator is just the least common multiple of the denominator. Okay? That's what LCD is. LCD is the least common multiple of the denominator. So make sure you're clear on that. All right, so we're going to identify the least common denominator of two fractions first before we start adding things together. So this is the set of rules that's in the textbook. I find it to be a little bit tedious to list them in columns, so I go ahead and use exponents. So instead of factoring it into columns and bringing it down, I use exponents. But if you'd like to use the method in the book, you can go look at the book. So you're going to use the exponents, and you're going to use the highest degree, which is the exponent, right? That's what we call it, the highest degree on the number, the exponent. All right, so we're going to find the least common denominator for the following pairs of fractions. In other words, find the least common multiple of 12 and 18. That's what we're finding. Okay, so let's list 12's factors. Now you may have to go off to the side and find the primes of 12, and I would recommend doing that. So we've got 3 times 4, so there's 3, and 4 is 2 times 2. Okay, so this is 2 squared times 3. All right, so 2 squared, there's our 2's column. Then our 3's column is going to have a 3 just to the 1 power. Okay, so now the 18 is the other one we need to look at. So we'll have 18, and I'm going to say 18 is 3 times 6. 3 is prime. 6 is 2 times 3. 2 and 3 are prime. Now let's write that in factored form with exponentials. Okay, so we're going to say 2 to the 1, or just 2, times 3 squared. All right, so 18 is here's our 2's column and our 3's column, 2 to the 1 and 3 squared. Now the book lists every single 2 and every single 3, but I find that this is just a little bit more succinct, a little faster, and hopefully will help you make sense of this. So what you want to do now is you want to look for the highest degree. We've already done this, but we're doing it again because I want to remind you how to do it. You want to look for the highest degree of every number. So on the 2, what is the highest degree? Well, that is the 2. Okay. On the 3, what is the highest degree? Well, that is the 2. Okay, so the least common multiple of 12 and 18 is going to be 2 squared times 3 squared. That's 4 times 9, which is 36. So the least common multiple of those two numbers is 36. That will be the least common denominator of the two fractions. And we're not going to take that any further right now. We're just going to practice finding the least common denominator. All right, so you do the same exact process. I'll move this up a little bit so you can see it while you work. Do the exact same process for this one and pause the video and see what you can do with it. Okay, so you are finding the least common multiple of 15 and 24. Okay, so let's have 15 here, and then we'll put 24 below. So I'm going to do 15, and that is just going to be 3 times 5, right? So there we go. There's no 2, so I'm going to leave the 2's column blank, and I'll put 3 to the 1 times 5 to the 1. All right, so the next one is 24. So 24 is going to be, we're going to factor that, and we're going to get, it doesn't really matter where you start, 2 times 12, 3 times 8, 4 times 6, it doesn't matter. Just pick one and just keep factoring until you get all the way down to prime. So 4 is 2 times 2, so those are primes. 6 is 2 times 3. So if you're in doubt, double check 2 times 2 times 2 times 3, put that in your calculator, you should get 24, your original number. So let's write this as exponential form, 2 cubed times 3. All right, so here's our 2's column, 2 cubed times 3 to the 1. And then the 5's don't have anything. All right, so now we're going to find the least common multiple, okay, is going to be, look at the 2's, which one has the highest degree? Well, there isn't anything in the 15s, so it's going to be that one. So 2 cubed. And the 3's are both the same, so just 3 to the 1. And then what about the 5's? We're looking right here. Well, there's nothing down below, so the highest power, of course, is 1. All right? So now you're going to take that. 2 cubed is 8. 8 times 3 times 5 is going to give you 120. And you can use your calculator if you want to. 2 cubed, you can say 2 times 2 times 2, which is 2 cubed. Use the button on your calculator, times 3 times 5, 120. So that is the least common multiple of 15 and 24. Okay, so that is practicing finding the least common denominator. So equivalent fractions property is important here. Okay, so we did this first a few days ago to make sure that you understood equivalent fractions first, because we need it to be able to do fractions, to be able to add and subtract fractions. So easing into this, we're going to convert the equivalent fractions using the least common denominator. So I'm sorry, convert two equivalent fractions using the least common denominator. We're not going to add or subtract, just converting so that they are equivalent to each other. Okay, so the first thing you have to do is find the least common denominator, which of course is the least common multiple of 4 and 6. So what is that? Well, some people might just multiply them together, but if they're not prime, that doesn't work. So that's not the least. So 24 is a multiple, a common multiple, but a smaller one would be 12. So you can go through the process we just did, but with small numbers, it's usually something you can think through if you have your multiplication facts down. Okay, so the least common multiple is going to be 12. Okay, so does 4 go into 12? Yes. Does 6 go into 12? Yes, it's the smallest number I can think of. Okay, so let's look at 3/4. So how could we convert 3/4 times something to have a denominator of 12? What would we multiply by? And then we're going to do 5/6. So what would we multiply 5/6 by to get a common denominator of 12? So pause the video and think about that and try to do it. All right, so 4 has to be multiplied by 3 to get 12. So that means we have to, if it's equivalent, right, equivalent, this number has to be, remember, a over a equals 1. All right, so it has to be the same number, top and bottom. So now our new number on top is 9/12. All right, what about the next one? What do I need to multiply 6 by to get 12? And that is going to be 2. So that means I have to do 2 on top as well. 5 times 2 is 10. So now I have these two equivalent fractions that have become 9/12 and 10/12. Okay, so now we'll be able to add them, subtract them. It's called combining. Okay, so we can combine those now because they have the same denominator. All right, so let's try that again. We already did 15 and 24 right up here, so we know the common denominator is 120, so we'll save time on that one. So it's 120, so go ahead and try doing this one. All right, so the least common multiple of 15 and 24 is 120. Okay, so we need them both to be 120. All right, so we are going to say, let's start with the first one, 4 over 15 times what equals something over 120, and 5 over 24 times something equals something over 120. Okay, so pause the video and work that out. All right, so how could I figure out what I'm going to multiply 15 by to get 120? Well, just divide 120 by 15 and you get 8. So I need to do 8 over 8, and this becomes 32. Same with 24. Divide 120 by 24, and I get 5. That means 24 times 5 is 120. Remember, multiplication and division are just reverse operations of each other. All right, so I've got to put 5 on top, and I get 25 here. So that means my two numbers that are equivalent fractions is 32 1/20ths and 25 1/20ths. And we can combine those now if we need to. Add, subtract, whatever we need to do. We could make them into pies with 120 divisions, and we would be able to put them together. All right, so now we're going to move into adding or subtracting. So the first step is always to find the least common denominator, and then we're going to convert to an equivalent fraction like we just did, and then we add or subtract just like we've done in the past. So once you get the common denominator, you just do it as you did before. So go ahead and take a look at this first one and give it a try on your own. All right, so what is the least common denominator? Remember, it is the least common multiple of 2 and 3. Well, they're both prime, so you can just multiply them together to get 6. Okay, so 6 is the least common multiple. Okay, so now first one we need to say 1/2 times what is going to give us something over 6, because this is our new denominator. That's what we're looking for here. It's our new denominator. All right, and then the other one is 1/3 times something equals something over 6, our new denominator. So if you didn't get this far, pause the video and try to take it from here. All right, so we've got 1/2 times 3 over 3 to get 6, so now we've got 3/6. And we've got 1/3 times, what's 3 multiplied by to get 6? Well, 2. 2 over 2, and we get 2/6. So now we've got our two equivalent fractions, and we have to add them. So we've got 3/6 plus, because that's what it says there, plus 2/6. That's 1/2 plus 1/3. Okay, so now we get to just say 3 plus 2 over 6 is 5/6. All right. All right, so here it is visually, and you can go look at it on the polypad if you're in OneNote. And you can see that 1/2 has been changed to 3/6, and 1/3 has been changed to 2/6, and now it becomes 5/6. All right, so here's another example. Give this one a try, and remember we are subtracting a negative, so what does it turn into? So pause the video and give this a try. Okay, so I'm going to try this one a little differently. Instead of listing everything down below, I'm going to do it all in one line. And you can keep doing it down below if you'd like, but I'm going to show you the long bar method that I use, and it just kind of speeds things up a little bit. So first we have to find the least common multiple of 4 and 2, and that is 4, right? So 2 times 2 is 4, so that's pretty simple. So we want them to be 4. So do I have to change the first number? It's 1/4. I don't have to change it, so I'm just going to have 1/4. All right, now minus a negative is just going to turn to a plus. And I need to take the 1/2 and I need to do something to it to turn it into 1/4 or something fourths. So some fourths. So what do I need to multiply 2 by to get 4 on the bottom? And that is going to be times 2. So we got to do it top and bottom. So this is I call it long bar method because I change this and I lengthen it, right? So now let's rewrite this as 1/4 plus 2/4. So we multiply these and we multiply these. So now I've got a common denominator. And again, you can write all of this down below if you want to, like I did right up here, and then combine them, and that is totally fine. Totally fine. All right, so we've got, I'm going to take this one step at a time, 1 plus 2/4, so we've got 3/4. All right, next one, 7/10 plus 8/15. So give that one a try. All right, so I'm going to have 7/10 plus 8/15. And I've got to find the least common denominator. So what is the least common multiple of 10 and 15? So let's look at the other way of doing this. I showed you the prime factors method, but with a little bit smaller numbers like this, it might be okay to just go, okay, 2 times 10 is 20, 3 times 10 is 30. Ooh, wait, let's stop there because I think 15 times 2 is 30. Oh, there we have it. There's our least common multiple. So 30. Okay, so how are we going to make 30 out of 10? I'm going to multiply it times 3, and that will give me 30. So now I've got to multiply that times 3. All right, so that one's taken care of. Now what about this one? 15 times what is 30? And that's going to be 2, so I've got to do 2 on top. So don't take shortcuts more than this, okay? This is a pretty big shortcut, so don't do any more than this. So you want to make sure you write all this down. 7 times 3 is 21. The bottom is 30. And then we're going to say on the other one, 18 times 2 is 16, and the bottom is 30. All right, so now we get 21 plus 16/30, and 21 plus 16 is 37/30. If it wants mixed numbers, this would be 1 and 7/30. 7/30. Okay, and if you don't know how I did that, pause the video and give it some thought. Okay, so let's try a subtraction problem and a number with negatives. So pause the video and see what you can do with this. Okay, so the top is the same, but the bottom is not. So we're going to have to find a common multiple of 10 and 35. So I might do this with a listing method because again, I think we're going to find it pretty quickly. So 35 is going to be 70. Oh, look, that's divisible by this is times 2, right? Times 2 is 70. So that's divisible by 10. So that's going to be the least common multiple. Now, if you don't find the least, it's not the end of the world. As long as it's a multiple, you'll just have to reduce when you get to the end. All right, so let's take the first one and say, all right, we're going to say 3/10, and then there's a minus, and then we're going to have 3/35. All right, but we want 70, okay? We want 70 on the bottom. So 70 is our least common denominator, or least common multiple of the denominator, okay? So 10 times what equals 70? Well, that is 7. 35 times what equals 70? That is 2. So we're going to do 2 on top and bottom. And now we get, over on the right, 3 times 7 is 21. The bottom should now be the same, right? So I've got minus 3 times 2 is 6. 35 times 2 is 70. All right, so now I've just got 21 minus 6 is 15 over 70. And sometimes even if you did reduce as far as you can go, it still needs to be reduced. So let's reduce this. So I see that 15 is made up of 5 and so is 70. So I'm going to have 5 times 3 on the top and 5 times what? Well, you might need to use a calculator. 70 divided by 5 is 14. All right, so now hopefully you see that the 5s then divide out to make 1 or cancel, whatever you want to think of there, and we get 3/14 as our final answer. All right, the next one. So another way to write this, remember, is negative 17 over 28 plus 5 over 12. All right, now negative 17 plus 5 is the same thing as 5 minus 17. So if you want to rearrange it to say 5 minus 17, you can, whichever way your brain thinks of it best. All right, so I need to find the least common denominator of this, and you can do it by listing, but I'm just going to refresh your brain on how to do the prime factors method. So the least common denominator of 28, the factors of 28 are 4 and 7, and then 4 is 2 times 2. Right, so we've got 2 times 2 times 7, so 2 squared times 7. And 12 is 4 times 3, so there's my 3, and 4 is 2 times 2. Notice I do this a little differently every time, so 2 squared times 3. So what is the least common denominator? You find it by doing this. I'm going to say 28 is 2 squared. I'm going to leave the 3 blank and the 5 blank, and then the 7 is just to the 1. All right, so then the next one is 12. So 12 is 2 cubed times 3 to the 1. All right, so now there's nothing in the 5s for either one, so we don't have to worry about the 5s. But now what is the least common multiple of these? We're going to go and we're going to look at the 2's. And what is the highest number on the 2's? Highest degree. The highest degree is the 3 right there. Then let's look at the 3's. What's the highest degree? Well, there isn't one in the top, in the red one, so it's just 1. There are no 5's, and then 7. So when you multiply all that together, 8 times 3 times 7, you are going to get, I think I did something wrong. I did, because it's wrong. I messed up. I wish I could undo this video and redo it, but I can't. So I'm going to show you where I messed up. Where did I mess up? Can you find it? I put a 3. It should be a 2. So be careful. Squared. All right. I knew that it wasn't that big. I knew it was what it was supposed to be. So we've got 4 times 3 is 12 times 7 is 84. So the least common denominator is 84. You could also do this by the listing method. You could just say 12, 24, 36, 48, and keep going, and then do the same thing with 28, and you will find the least common multiple of those two numbers by listing. Okay, so sometimes that's the hardest part of this, is finding the least common multiple. Okay, so let's start with the first one. We've got negative 17 over 28, and that's going to be plus, and we've got 5 over 12. Now I'm using the long bars so that I can work this out. So 17 and 28 are going to be times 3 and times 3 to get me up to 84. And 5 is going to be times 7 because 12 needs to be times 7 to get up to 84. So remember, we just need 84 on the bottom. All right, so now let's rewrite this one as 17 times 3 is 51. So don't forget your negative. Negative 51 over 84, right? Plus 5 times 7 is 35 over 84. Now, if you get here and you have a different denominator, you messed up somewhere, okay? So be careful. All right, so now we get negative 51 plus 35, or 51 minus 35, and then it's going to be negative, and you get negative 16 over 84. Now, I see right away that both of those have a 4 in them. So I'm going to do this with the shortcut method. I see there's a 4 in 16. How many 4s are there in 16? There are 4. how many 4s are in 84. Use your calculator if you need to. And I find that there are 21 4s in 84. So the final answer here is negative 4 over 21. Okay? All right, next one. This one's a little tricky. Give it a try. See what you can do with it. All right, first let's find the least common denominator of 6 and 15. And I found it to be, I'm not going to work all of these out because it will take me forever. I found it to be 30. And you can stop and see if you can figure that out. And so I've got n over 6 plus 11 over 15. And what do I need to multiply both by? So 6 needs to be multiplied by 5 to get up to 30, right? Trying to get to 30. And so 5 top and bottom. And then what do I need to multiply 15 by? Just 2. All right, so now let's write what we get. Now what is n times 5? We typically are going to write that as 5n, right, over 30 plus, so write it in the order with the number first, we call that the coefficient, 22 over 30. So let's rewrite this as 5n plus 22 over 30. And we are done. There's nothing more you can do with that. You cannot divide out the 5 and the 30 because you would need to do it to the 22 also. Remember, it's factoring out. So since there's a plus, we can't do it. All right, so next we're going to simplify complex fractions that contain several operations. So remember, a complex fraction is just division. This thing right here means division. So 3/4 is this one, and 5/8 is this one, and the division sign is in between. So simplifying complex fractions, you want to simplify the numerator and then the denominator and then divide the numerator by the denominator. All right, so these are challenging. So one step at a time, let's try them. All right, so the top, 1/4 squared means, it means 1/4 times 1/4, right? So in fact, I'm just going to write that here. So we've got it. So we've got 1/4 times 1/4, and that is over 2 squared is 4 plus 5. All right, so on the top, 1/4 plus 1/4, just multiply the top to get 1, multiply the bottom to get 16. And that is going to be over 4 plus 5 is 9. All right, so now this is a division problem. So let's rewrite it. Let's rewrite it as 1 over 16. I want to keep my colors. 1 over 16. And I want to make this one green. So let's stick with our colors. 1 over 16, and it's divided by 9. All right, so remember 9 is just 9 over 1. Now keep, change, flip. So this equals 1 over 16, keep the first, change to multiplication, and flip the second one. Okay, so nothing cancels. There's only 1s on top. So we end up with 1 over 16 times 9 is 144. One step at a time. Don't make them harder than they are, and try not to get overwhelmed by the number of numbers, just one step at a time. All right, so we are going to look at the top as one problem and the bottom as a different problem. Okay, so let's do them one at a time, but I'm going to do them all together so you can see them. I like to keep my problems together instead of writing all over a piece of paper and kind of losing what I'm doing. So let's start with the top and say, what is the least common denominator of the top of this thing? So 2 and 3, that's going to be 6. Okay, 6. What is the least common denominator of the bottom? 3 and 8. So hopefully you see that that is 24. And if you don't, go try it and see what you can do with it. Okay, so I'm going to have to write pretty small here, but maybe I can extend things here. Move this out of the way. All right, so now we've got 1/2 times 2/3 is one problem. All right, so I've got 1/2, and I'm going to extend the bar, plus, sorry, I meant plus, not times, plus 2 over 3. All right, 1/2 plus 2 over 3. All right, so what do I need to multiply on the top to get a 6? I'm going to have to multiply times 3 over 3, and here I'm going to have to multiply times 2 over 2. I'm just going to keep going with the top, so I know there's another bar here, but we're just going to do the top. Okay, so now 1/2 times 3/3 is going to be 3/6. So I get 3/6, and then I get plus, then this one is going to be 4/6. 4/6. Ooh, my bar didn't need to be quite so long, did it? So I'm going to shorten that. There we go. So 3/6 plus 4/6. All right, let's take that a step further, and I get 7/6. Now I'm not going to change it to a mixed number because we have to do more with it. We have to use this division right here. Okay, so I've got the top as simplified as I can. Now I'm going to go back and I'm going to do the bottom. All right, so the bottom, I've got 2/3. I'm going to do my long bar, plus or minus 1/8. Okay, so it's going to be minus. All right, so what was my common denominator? And that was 24. So how am I going to make 24 out of 3? We're going to multiply it times 8, so top and bottom. And with 8, I have to do times 3. All right, so let's come over here and say 2 times 8 is 16 over 24. 16 over 24 plus, the next one is going to be 3 over 24. 1/8 becomes 3 over 24. All right, oops, not plus, minus. Okay. All right, so now I can combine those to get 16 minus 3 is 13 over 24. All right, so now what does this thing mean, right? It means division. So that means I can take the top one, which is going to be 7 over 6, and it's going to be divided by 13 over 24. All right, keep, change, flip. So I'm going to say keep, change to multiplication, flip to 24 over 13. All right, so this is going to become 7 times 24 on top and 6 times 13. Now notice I did not multiply because I see that 24 and 6 have 6 in common. So what am I going to do with that? Well, I'm going to say how many 6's are in 6? 1. How many 6's are in 24? 4. Okay, so now I get 7 times 4 on top, which is 28, and 1 times 13 on the bottom. Now, if it wants mixed numbers, you're going to change this to how many times is 13 going to 28? 2. 2 times 13 is 26. What's left over? 2 13ths. Okay, so those are my answers. All right, these are long. All right, there's another one. It's going to be a long video. All right, so give that one a try, see what you can do with it. All right, so the top is 7, which is just 7 over 1. What's the least common denominator of the top then? So the least common denominator is just 9. Okay, so how do I change 7 over 1? So let's write that down. So let's change it to 7 over 1. And then I'm going to say minus, I'm just going to say 1/9. I'm not even going to use a long bar because I know it's 9. Okay, over. Now I've got 5 over 12 and another minus, and this one is 1 over 3. What is the least common denominator of 12 and 3? So don't jump to multiplying them. Think, does one go into the other? It does. So the least common denominator of this is actually 12. So did I need a long bar on the first one? No, I did not. I did not need a long bar. So I'm going to redo that, and I'm just going to say 5/12. Okay? All right, so keep track of everything you're doing here. The top, let's go back to the top. We're just going to work the top all the way across. All right, so try to stay focused on one thing, which I did not model very well just now, did I? So stay focused on the top and then come back and do the bottom. So the top, we decided the least common denominator is 9. So I'm going to say times 9 times 9. All right, so now I've got on the top, I've got 63/9. Does that make sense that that is 7? 63 divided by 9 is 7, right? Just make sure that makes sense to you. Minus 1/9. All right, 63/9 minus 1/9 is 62/9. We're going to leave it like that. We're not going to try to reduce or anything. It doesn't really reduce, but we're not going to because we still have more to do with it. All right, 5 halves over 1/3. What do I need to do, or minus 1/3? What do I need to do to the 1/3 to get the least common denominator of 12? So times 4 top and bottom. All right, so I get 5/12. Still, I don't want to change that. Minus, now what does this become? It becomes 4/12. All right, so now we've got 5/12 minus 4/12 is 1/12. Right, 1/12. And make sure I've got all my signs right. 5/12 minus 4/12. I wrote something down in my notes, so I'm just going to trust myself that I'm doing it right at this point. All right, so I've got 62/9, and remember that this just means division. So I've got 62/9 divided by 1/12. Keep, change, flip. 62/9, change to multiplication, 12 over 1. All right, so now I'm going to say 62 times 12. Why didn't I go ahead and write it out? Well, I see that 9, and I don't even need the 1 there. 9 and 12 both have a 3 in them, so I'm going to think to myself, how many 3's are in 9? 3. How many 3's are in 12? 4. All right, so now I think I'm done. So 62, because 3 does not go into 62. All right, so 62 times 4 is 248 over what's left on the bottom, 3. Or how many 3's are in 248? There are 82. 82 times 3 is 246. So how many are left over? 2. So 82 and 2/3. Okay, so either one of those is fine for me. So just pay attention to what Lumen is asking for. All right, so now we're going to evaluate variable expressions with fractions. This is no different from evaluating other expressions. It's just a little bit harder. So evaluate z plus 2/3 when z is negative 5/3. All right, so that means we're just going to take this and we're going to plug it in for the z. All right, so I get negative 5/3 is what I'm plugging in for the z, plus 2/3. All right, so that means I get negative 5 plus 2 over 3. And that becomes negative 3 over 3, which is just negative 1. Remember, 3 over 3 is just 1, and there's a negative there. All right, so here's another one. Evaluate that when we have two different numbers. Give that one a try, see what you can do with it. All right, so I've got 7 times something squared times something else. So this is where my r goes and this is where my m goes. So I'm going to take my r and I'm going to put in that 1/2 right there. And I'm going to take my m and I'm going to put my 5/6 right there. So now just work it like you would anything else. All right, so I've got 7 times, now 1/2 squared is going to mean 1/2 times 1/2, right? So we square the top and we square the bottom, basically, over 5 times 5/6. All right, so I get 7 over 1 times 1 over 4 times 5 over 6. Okay, so that's one way to think about it. I don't see anything that cancels or divides out because the bottom is all even, the top is all 7 and 5, and those are both prime. So there's nothing really that I can do besides just multiply across. So I get 7 times 1 times 5 on top and 1 times 4 times 6 on the bottom. You can ignore the ones, and you get 35 over 24, which equals 1, because 24 goes into 35 once, with 11 left over, 11/24. All right, one more. All right, try that one. Okay, so I left some blanks. This is where the A goes, and the B and the C. Okay, so I'm going to put the A in here, -7 plus -2 over +3. So be careful. Those are really easy to screw up. All right, so on the top I've got -7 plus -2 is -9 over 3. So remember, simplify the top first, then the bottom, and then you can divide out. So what's negative 9 over 3? In other words, what's 9 divided by 3? 9 divided by 3 is 3, and there's a negative there. So negative 3. Okay, that is it. Thanks for watching all the way to the end of this very long video.